right, guys. So we're going over the review sheet today. And then we will have your test afterwards. I believe we'll get through pretty much all the review sheet today, so your test will be tomorrow. Now, looking at questions 1 through 4, determine if the following are one-to-one functions. So one-to-one is just saying that the y values are not repeated. That we don't have two different x values going to the same y. Awesome. Thank you. So if we look at number 1, so we can look at the x values. Now the x values are repeated, so it is a function. -7, -3, 0, 9, 3. And if we look at the y values, 14, 15, 7, 21, -15. So this would be yes. Because if none of the x values are repeated, none of the y values are repeated, it is one-to-one. Especially when we look at given points. If we look at number 2, -4, -2, 0, 6, 8, we look at the y as -2, -2. So this would be no. Now graphically, we're doing essentially the same thing, but we call it the horizontal line test. If we can draw a horizontal line and it crosses at more than one point, then it would not be one-to-one. So this here would be no. Because there's multiple places where it crosses more than once. If we look at number 4, at any of these points, there's only one of them at any of the given spots. So this would be yes. Any questions on 1 through 4? 5 through 8, find the inverse of each function. When we find the inverse, there are several steps. The first is we replace f of x with y. Now, if they already have the function as y equals, we don't need to do this step. Our next step is to switch x and y. So we say x is equal to 16y minus 9. And then the next step is to get y by itself. So we can add 9 to both sides, telling us that 16y is equal to x plus 9. Then lastly, we're going to divide both sides by 16, telling us y is equal to 9, or x plus 9 divided by 16. And once we get it all the way solved, get y by itself, we'll say f inverse of x is equal to x plus 9 over 16. Now we say f, we use f because the starting function was f of x. So if the starting function had been g of x, we would say that our inverse would be g inverse of x. Questions on any of this here so far? Now, if we look at number 6, we'll treat it in a similar fashion. We'll replace f of x with y is equal to 6 times the square root of x minus 4. Switch x and y. X is equal to 6 square root of y minus 4. At this point here, we're going to get y by itself. So the first thing we'll need to do is get the radical by itself. So we're going to divide both sides by 6. So we say x over 6 is equal to square root of y minus 4. To simplify the radical, we will square both sides, which the left-hand side, the numerator is going to be x squared. The denominator is 36 is equal to y minus 4. Last but not least, we're going to add 4 to both sides, telling us y is equal to x squared divided by 36 plus 4. Or in our case, it would be f inverse of x is equal to x squared over 36 plus 4. Any questions on how we found this inverse? Now, technically, I'm not going to count off. I'm not going to deduct points for this, and I don't think the professors over at NEO would either. We would technically have to give a restriction for the value of x. That x has to be greater than or equal to 4. Because our starting function, 6 times the square root of x minus 4, our values of x cannot be less than 4. If they are less than 4, we don't have any values there. So we would have that there, and I don't, let's see here, because it would be that when x is 4, y would be 0. So here the domain is greater than or equal to 4. Our range would be greater than or equal to 0. So here, actually, I have it flipped. This would not need to be 4, but it would need to be 0, the range. Because the quadratic function is left and right, it's not going to be the complete inverse. We only need half the inverse. Because starting function is going to be this here. Its inverse should only be this here. Let's look at number 7, I think y'all will feel comfortable with 8, as 8 is very similar to 6. It's just instead of square rooting or squaring both sides, we square root both sides. Similar process. So again, with finding the inverse, the first thing we do is replace f of x with y. Then we switch x and y. And the main difference from this one, with this one, than the others is that we have y in more than one place. So, first thing we do need to do is get rid of the fraction by multiplying both sides by the denominator. On the right-hand side, they will simplify out, leaving us with just 8y minus 7. On the left-hand side, we will have to distribute, which will give us 4 times x is 4x, minus 5y times x is 5xy. Now that we do have this here, we don't have any fractions. We need to get the y's together and everything else on the other side. So what I can do is add 5xy to both sides, which will tell us that we do have 8y plus 5xy minus 7, and we have 4x over here. Then we can also add 7 to both sides, telling us that we have 4x plus 7 is equal to 8y plus 5xy. Now, if you wanted to have done both of those steps in one motion, you could have, because we could have added 5xy and added 7 at the same time and would have gotten to the same place. Now that we've gotten here, we can divide or factor out y from both the 8y and 5xy. Because if I factor a y from 8y, we have 8 plus. If I factor a y from 5xy, we have 5x. And now that we've done that, we only have one y left in the entire equation. And to get it by itself, I'm going to divide both sides by 8 plus 5x. These two will cancel, leaving y by itself is equal to 4x plus 7 over 8 plus 5x, telling us that f inverse of x is equal to 4x plus 7 over 8 plus 5x. Any questions on any of these inverses? Any questions over anything we've done so far? Questions over number 8? Or do we feel good with number 8? 9 and 10, determine if the following functions are inverses. For this one here, we do our f of g of x. It's equal to g of f of x is equal to x. Both of these need to equal the same thing, and specifically they need to equal x. If they come out to anything other than just x, they are not inverses. So for number 9, we can start off with f of g of x. And with our composite functions, we work from the inside out. So for the first part, I'm going to replace our g of x with the function g of x. So we'll have f of the square root of x minus 14. At this point here, we're going to plug the square root of x minus 14 into x, which tells us we have the square root of x minus 14 squared minus 14. Luckily for us, the square root and the square will cancel, telling us x minus 14 is equal to x minus 18. So our f of g of x is x minus 18. Questions on any of this so far? Now we can do the same thing going the other direction. So the first thing we'll replace is f of x with its function, x squared minus 14. And then we can plug this in place of x in g of x, which would be the square root of x squared minus 14 minus 14. Which this here is just going to be this x squared, well, negative 14 minus 14 is negative 18. There's no way to simplify that because it's not, we cannot write it as a single set of parentheses squared, so there's no way to simplify the radical. So this is what we get, and it's kind of telling us that, well, f of g of x is definitely not equal to g of f of x, which is most certainly not equal to x. So are these inverses? No, they're not inverses. Because if they don't equal x, then they're not inverses. And for the most part, I could have found that out after we did the first one, because if one's not equal to x, the other one's not going to be equal to x, so it's not going to work. But I do want you to at least do both on the test, show me both, and then tell me if they are or not inverses. Because if we did the other one, f of g of x, well, g of x is our x plus 15 divided by 12. Then we take that and plug it into f of x, which is 12 times x plus 15 divided by 12 minus 15. And at this point we simplify. Well, the 12 and 12 will cancel, telling me that I have x plus 15 minus 15, which is equal to x. So f of g of x is x. Questions on this here so far? Now, going the other direction, we start off by plugging in f of x's function for f of x, which gives us g of 12x minus 15. And then we plug this in place of x in g of x, which gives us 12x minus 15 plus 15, all divided by 12. On the numerator, our negative 15 plus 15 is 0, which just leaves us with 12x divided by 12, which is x. So g of f of x is x, which tells us for this function here that f of g of x is equal to g of f of x, which is equal to x. So yes, they are indeed inverses. Questions on any of this here? Write each logarithmic form as exponential form. That is a very clunky sentence. But all we're doing is changing it from logarithmic to exponential. Now we can use our set formula that log base b of x equals y is true if and only if b to the y is equal to x. We can use this form to go from one to the other. So for this one here, we would say 7 to the negative 3 is equal to 1 over 343. Or I can do this for number 12. The base is 2. So I know if I put it to the base 2, the 2 and the log base 2 will cancel. I can put 2, telling me 2 to the 12th is 4,096. Because these here would cancel. Now the nice thing with any of these here is that we could actually check them mathematically. So for number 12, 2 to the 12th, 2 to the 12th is 4,096. It is a true statement. 7 to the negative third is 1 over 343. So for both of these here, we could plug them in and check to make sure that they do work. So especially with the numbers, we can make sure that they work. The natural log, well, its base is e. These would cancel, telling me e to the 15y is equal to 3x. We could have it flip, say 3x is equal to e to the 15y. Either way works. But this one here we can't check because we don't know the value of x or y. But this is what we get. Questions on these here? Now going the other direction, we can use the formula that we just had, flipping it from one to the other, or we can apply the log to both sides. So here I can apply ln. ln into b simplifies to just 7x. And the other side we have ln of 9y. On the next one, we can apply log base 6 to both sides. This cancels out, leaving us with 3 is equal to log base 6 of 216. And as we've seen with that one, so I can quit math, log base 6 of 216. I can check it in the graphing calculator. It tells me it is indeed 3. So plugging it in is a good way to check to make sure, is it giving us a true statement. And the last one, we can apply log base 1/2, which tells us log base 1/2 of 64 is equal to -6. Any questions on 14, 15, or the supposed to be numbered 16? We good with these here? Expand the logarithm. So we expand the logarithm. Expanding, we're going to do division property, multiplication property, and then power property. This is the order I would do these in. So when we look at this first one here, we would do the division property, because the division property states that we can rewrite division inside the logarithm as subtraction. We can write what's inside the logarithm, what's divided inside the logarithm as subtraction. Then from there, we can use the multiplication property, which states anything that's been multiplied inside the logarithm can be rewritten as addition of those logs. So for the first one, we'd have log of 8 plus log of x to the third plus log of y squared minus. We have to be careful with the minus because it's going to have to be applied to all of the ones that are in the second one, so it's good to put a parenthesis and then apply our multiplication property. So log of w squared plus log of z to the fourth. Now, if you can remember to just make both of those negative, that's fine. You don't necessarily need to put the parentheses. Yes, thank you. Now, we can do the power property. I'm not going to be focused on these here, log of 8. If it does reduce nicely, go on and reduce it. But here, I'm not going to expect you to rewrite 8 as 2 cubed, so that then we have 3 log 2. Log of 8 is fine. But for the next one, x to the third, we can move the 3 out in front, telling us that we have 3 log of x. Plus, for y, we'll have 2 log of y. Now we can make both of these negatives and move the power. So for here, the 3 would come to the front, telling us that we have 3 log of w. And because it's part of the division, it's in the denominator, it would be negative. The same for log of z to the fourth. It's going to be negative. We can move the 4 up front, telling us that we have 4 log of z. And one way that you can look back and make sure that you do have the signs correctly is that if it started in the denominator at the beginning, the sign in front of it should be negative. If it was in the numerator, the sign in front of it should be positive. But that's it. Any questions on 17 or 18? Do we feel good with these two? Because 18 is not any different, except instead of writing log, we're just writing ln. Nothing changes. Going the other way, condensing. Our first one is going to be powers, then man, my brain is spaced. Multiplication. And then really our next one is just to simplify powers, because I found the easier or kind of easier way to do this is when we take the exponents, take the signs, the negative signs with them. So when we look at this here, we take the exponents for all these here and the negative signs. So for our first one, we'd have log of x to the third. Plus, since we take the negative with it, we'll have log of y to the negative 7th. Plus, here we bring the 3, log of 2 to the third. And last, we have plus log of t to the negative 1. Since we have more than one thing added together, more than one log added together, we can rewrite it as multiplication. I'm going to move the 2 to the third to the front. Then we'll have x to the third, y to the negative 7th, t to the negative 1st. Multiplying them all together. Now we do have to make the exponents positive, so to make them positive we move them from the numerator to denominator or denominator to the numerator. Here in this case we're moving them to the bottom of the fraction, which would be our y and t. Now since t is just to the negative 1st, when we move it down it becomes t to the 1st or just t. Y to the negative 7th goes to the denominator and becomes y to the 7th. The numerator, x to the third will stay put. And 2 to the third is, hey, go on and simplify those powers. I'm not going to make you rewrite 8 as 2 to the third. But if we do have 2 to the third, go on and simplify it to 8. Any questions on this here? Any questions on number 20? We feel good about number 20. Evaluate each expression. Plug them in. If you're not sure, plug them in with most of these here. Most of them should work out nicely because 21 is 4. This here, math, log base 7 of 16,807 is 5. And do we know what 23 is? 100. Log base 10 of 10 is 1, so 100. So these here we can just plug them in and evaluate. Let's look at 24. Now there's different ways we can go about 24 because we can apply ln to both sides and solve. We can apply log base 5 to both sides and solve. But one thing that is nice about 24 is 125, incidentally, is 5 to the third. And the reason I say that is because if we change 125 to 5 to the third, we now have the same base on both sides, which we can simplify the right-hand side, multiply through by 3, and we get this here, our one-to-one property. If the bases are the same, then the exponents have to be the same as well. So we're saying that 3x minus 7 has to equal 6x plus 9. The only way these two can be equal, with the bases being equal, is if the exponents are equal. And we can solve from here. We can subtract 3x from both sides. Minus 9 from both sides. Telling us that 3x is equal to negative 16. Divide both sides by 3, telling us x is equal to negative 16 thirds. And that's it. And that is the correct answer. If you're not sure, especially on the test, the answer comes up funky looking or doesn't look right, plug it in. Plug it back in to the original function and see, do we get the same answer? 5 to the 3 times negative 16 over 3, what was it, plus minus 7. Is this number here, 125 to the, what was it, 2 times negative 16 over 3 plus 3. Minus. They're the exact same value. They match up. Since they match up, that means that is the correct answer. Questions on 24. 25 is kind of nice because we only have a variable in one of the two exponents. So this one here, we'll use our log base. And the log base that I'm going to apply to both sides is going to be log base 4. And the reason we use this is because of this right here. Log base 4 of 4. Log base 4 of 4 is 1. And what we will do is move the exponent out front, just leaving us with 5x minus 7 is equal to log base 4 of 21. And at this point here, we're going to solve. So we'll add 7 to both sides, telling us that 5x is equal to log base 4 of 21 plus 7. And last but not least, we'll divide both sides by 5, telling us x is equal to log base 4 of 21 plus 7 divided by 5. Round to the nearest hundredth place, tenths, hundredths. So second decimal place equals enter math. Log base 4 of 21. I think it was plus 7 divided by 5. 1.839, so 1.84. And that's it. We can plug this one back in. We will get something close to 21, but again, since we approximated, we won't get the exact answer, but it would give us something close to it. Questions on either one of these here? Questions on 26 or 27? Well, 26, we'll go on and do it. The first thing we'll need to do is get e by itself. So we'll add 21 to both sides. Telling us that 4e to the 3x plus 7 is equal to 34. Next thing I would do is divide both sides by 4, telling us e to the 3x plus 7 is equal to 34 over 4. So for problems like this here where we have just one exponent, we get it by itself first. And after we get it by itself, we apply the appropriate logarithm to both sides. Here, we're going to use ln. Because according to our power property, we can move the exponent out front. Telling us that we have 3x plus 7. But luckily for us, ln of e is 1. Is equal to ln of 34 over 4. Now 34 over 4 does simplify a little bit, but not enough. I mean, if you wanted to change it to 17 halves, you can. There's nothing wrong with that. But I'm going to leave it as is at this point. The next thing we can do is subtract 7 from both sides. telling us that 3x is equal to ln of 34 over 4 minus 7. And last but not least, we're going to divide both sides by 3, telling us x is equal to ln of 34 over 4 minus 7 divided by 3. Any questions on any of this here? Now this one we can do in either calculator because ln of 34 over 4 minus 7 divided by 3 is negative 1.619 or negative 1.62. Questions on any of these here so far? 27 is very nice. Since we do have the same log on either side, we can just set what's inside of them equal. Or essentially we apply base 3 to both sides. They both cancel, just telling us that x squared plus 17x is equal to 2x plus 16. Since we do have a quadratic, we do need to get this equal to 0. So I can subtract 2x from both sides, telling us that x squared plus 15x is equal to 16. Minus 16 from both sides, telling us x squared plus 15x minus 16 is equal to 0. Now at this point here, you could factor it, you could graph it, quadratic formula, any method you want. X squared plus 15x minus 16, graph, we do have 2 points. One of them is at 1, and the other is at negative 16. Whenever we get 2 answers, it is good to check and make sure that both of them work. Base 3 of, so we can do 1 first. 1 squared plus 17 times 1 is equal to log base 3 of 2 times 1 plus 16. Now we could type this into the calculator. You don't have to type the whole thing in. I would just type what's inside the parentheses. So 1 squared plus, it was 16 times 1. Enter. Is, well, I was right with the first. It was 17. So it should give us 18. 17 is 18. Since it is a positive number, that is fine. It works out nicely. Our other side, 2 times 1 plus 16, well, 2 times 1 is 2, plus 16 is indeed 18. So x equals 1 is just fine. If we do the same thing to the other side, thank you. Base 3 of negative 16 squared plus 17 times negative 16. I need him for now. It's the time I'm going through this review. Thank you. Now on the other side, so we have negative 16 squared plus 17 times negative 16. So parentheses, negative 16 squared plus 17 times negative 16 is negative 16. So we have log base 3 of negative 16. Now, at this point, we really don't even have to do the other side because, again, we cannot have a negative inside the log. So we know this isn't going to work. Even though if we type the other one in, I'm also going to get negative 16. They are the same, but we cannot have a negative inside the logarithm. So even though that they are both, it is true, both sides are the same, since they don't have an actual value, they do not work. Any questions over any of this here? Okay. Now we definitely don't have enough time to go through any of the rest of these here, so we will have to finish this up tomorrow.